Hello and welcome to another episode focused on the home lab. Today we're going to look at fiber optics and fiber optic networking. And if you're new to fiber optics in the home lab, this will be a great introduction to hopefully everything you need to know to do fiber optics in your home lab. So we'll start with, here on the bench, we have some fiber optic patch cables. We have this one that's the aqua colored, which is a multimode fiber. And then we have this yellow one here, which is a single mode fiber. And multimode and single mode represent the two primary types of fiber that you're going to see in widespread commercial use. Now the multimode fiber, this is the aqua colored. This is an OM3 fiber. There are older versions, OM1 and 2, that are often orange colored. And there's a newer OM4 and OM5 that sometimes is violet colored. And I think the very latest sometimes is kind of a lime green colored. But this aqua color is by far the most common you're going to see for multimode fiber. On the single mode fiber side, this is a yellow coating, and a lot of the single mode fiber is yellow coated, but there are a few other colors for a couple different use cases. But these are the cables you're going to see sort of the most often in a production environment. And when you're talking about multimode versus single mode, the first thing you do is usually pull up a little picture. The difference between multimode and single mode. So multimode, the glass core is relatively large. It's a 50 micrometer core, and it's relatively large relative to the wavelength of light going through it. And the result is that when light goes through the cable, it can both go straight through, it could bounce off the side at different angles, and that results in the light coming through having many different paths that are all different lengths from the one side to the other side of the cable. And what that does is when you have a sharp transition, the light turns on, that sharp transition gets blurred or smeared over time the longer it goes down the cable because of these reflections. And that smearing of edges eventually limits the maximum speed you can run this fiber at, especially at longer lengths. So it affects both the ability to run a given speed and then the maximum length you can run that speed at. Meanwhile, in a single mode fiber, the core is much smaller. It is on the order of 8 to 9 micrometers, so it's 1/5 the size. And the wavelength of light usually is a little bit longer wavelength. Typically 1310 nanometer is a popular wavelength used in single mode fiber. There's a wide range you can use. And that results in what's called a single mode, where the light travels only through the center of the fiber and doesn't have reflections on the edges of the fiber. And that means that the light travels a relatively consistent length, the entire length of the fiber. And the result is you can get much higher bandwidth and much, much longer distances. So single mode fiber is the sort of best way if you want both high bandwidth and really long distances. And so as far as for the home lab, the multimode fiber is good for in the range of 300 meters or less. There are some modes where it's only 70 meters, but it's in that range of less than 300 meters. If you're more than 300 meters, then you're certainly in the range of single mode fiber. And so if you're going either 300 meters or as far as 80 kilometers, then single mode is the way to go. You might be thinking, well, so if single mode can do everything multimode can do, better, faster, and a lot longer distances, then why not do single mode all the time? And it's a fantastic question. And the answer is primarily cost. Now, in today's market, the difference of price for the actual fiber itself between single mode and multimode isn't that much, but the cost of the transceivers is a little different. There are some very inexpensive optical transceivers for multimode, especially for like multimode only like 70 or 80 meters, that are really, really, really low cost. Meanwhile, on the single mode side, they can vary in price, but they can be quite expensive for very long range optics. And so in general, multimode is a great solution for inside of a data center or inside of a home lab. Even inside your house, you're unlikely to have runs in your house go over 300 meters. So you can certainly use multimode fiber for those use cases. With that in mind, when I built my house, I did actually a combination of both multimode and single mode. And if you only had to choose one, then for putting in walls especially, then of course you should choose single mode because it gives you by far the most flexibility. It's just multimode can be a little less expensive in some environments. Some of the optics can be a little cheaper. And so if cost is the biggest factor, then the multimode fiber can be a good solution. One of the cool things about multimode fiber, kind of an amazing thing, is that it has improved over the years, in part because the fiber now has and we can show it in this little picture, the modern multimode fiber actually has a different index of refraction at the center than it does on the edges. The edges is a little less index of refraction, which means that light that takes the slightly longer path of going toward the edges of the fiber goes a little faster when it's on that edge, and that overall compresses that smearing and gives you a little better maximum bandwidth and maximum distance. And it's, if anything, just quite amazing that you can produce multimode fiber with those characteristics so inexpensively. It's quite incredible. So these fibers here are patch cables, and the connector on the end here is called the LC connector. And there are a number of different popular connectors in fiber optics, but the LC connector is probably the most common one you're going to see in a home lab. And that's because many of the optics that you're going to buy have LC connectors on them. So it's a very popular, there are little dust covers here that pop off, but they go right into the optic. And so LC connectors is probably the most common thing you're going to see in a home lab. And maybe number two, I have one here, would be a connector called MPO, which is a small connector, a little wider, but it has a total of 12 fibers in one connector. And we'll take a look at some of the microscopes. You can see what it looks like. It's kind of cool. We'll start looking at one of these because it's kind of interesting here. So let's pop over to the microscope. And so I have this sitting in the microscope. This is just a normal LC connector, multimode. And I have a little light going into it. And what's interesting is if I zoom in, and I can turn down the light a little bit there, so you can see that little red dot. That's the actual core, and this is a multi-mode core. So the single mode core is 5 times smaller than that. And so it is a very, 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 very small source of light. And the takeaway from that mostly is that these are very, very sensitive to dirt. A very small piece of dirt or dust could easily cover the entire surface that is transmitting light there. It's a very, very small connection. And so when you're doing fiber optics, it's important to be aware that they're relatively dust sensitive. And so there are some tools for cleaning the ends of these. And if you're storing them, make sure you put the dust caps on. And if you have optics, try to keep dust covers on those optics as well, because it doesn't take much to block that little tiny piece. Now, I mentioned that MPO connector as sort of an alternate connector. And let's take a look at that. We'll pop it out here. Let's zoom back out. So this is the MPO connector. Let me see if I can get this in here. Let's get that focused. Okay, there it is. So you can see the two big holes are mechanical holes for little alignment pins. And you can see the 12, we'll zoom in a little bit here. You can see where the 12 fibers are all coming to the surface. And so this pushes into a connector that has a flat, like a glass plane with fibers on the other side. And they just come in contact with each other. And it's really cool because you get 12 multimode fibers in this single little connector. And so it's a pretty neat way to get more than one set of fibers in a small cable. Let's go back over to the top view here. Now this MPO cable plugs into optics that have this MPO connector on it. And as I mentioned, it has 12 fibers that are in the connector, but there also are many of them that have only 8 fibers. And this is an example of one where there are 8 fibers in this connector, and the other end is 8 fibers broken out into LC connectors. And this has an advantage because if you have a switch that has an optic that has this MPO connector, you can then connect that with these to a switch that only has the LC connectors. Now, of course, there are 4 of these connectors on one side and 1 of these on the other. And so you have 4 entire connections from this one connector on versus 4 on the other side. And that'll be useful for the 40 gig connection where it's made up of 40 10 gig connections. And so as far as speeds go, the multimode fiber can do, obviously 1 gig and 10 gig, 25 gig, 40 gig, and even 100 gig. The one issue is that it shrinks the length you can do it with, depending on a couple things. The OM5 can go a little further. But multimode fiber can, in fact, do those higher speeds. Single mode fiber, of course, can do 110, 25, 50, 100, 200, 400, 800. The theoretical bandwidth is much higher than that. And so single mode fiber really has a tremendous advantage in especially the multiple wavelength optics of doing a tremendous amount of bandwidth. And it really is the choice for obviously long distance, especially because you can go, like I said, 80 kilometers versus 300 meters. So in terms of selecting one or the other, the price is a big factor as it relates to the multi-mode. But if you're going any distance at all, you're going to have to use single mode. And there's no reason why you can't use both. In fact, with that in mind, let's switch gears and take a look at what we call the optics or the modules, because that's really where most of the magic happens. So let's talk optics, or perhaps more correctly, modules that fit into ports where optics would go. And so in the world of the home lab and the kind of equipment we're probably going to have, there really are two major physical form factors that are pretty common. There's the SFP form factor and the QSFP form factor. There are other form factors bigger than this, like OSP and CFP, but those are things you're probably not going to see in a home lab, at least not right now. So of these two form factors, you can see the QSFP is slightly bigger than the SFP. It has more pins and it's a physically bigger package. So within the SFP physical family, there are three different types of SFP modules that fit into that physical form factor. The first is the original SFP. And so these are with the optics, and in this case, this is a copper interface. And this interface electrically can do 1 gig transfer. So in other words, everything you see where you see an SFP port, you can plug in an optic, or in this case, a copper interface, and it can do 1 gigabit Ethernet. And so you can find single mode and multi-mode optics for that 1 gigabit Ethernet, and they can plug into an SFP port. And so when you see a switch, you sort of know SFP means they can do up to 1 gigabit. SFP Plus is sort of the next higher level, and SFP Plus is the same physical package, and the electrical interface is, instead of being a 1 gigabit interface, it's a 10 gigabit interface. It's actually between 9 and 11. There's some variability there based on the use case, but it supports 10 gigabit Ethernet at the end of the day. And so those modules come in, again, multi-mode or single mode optics. You can also get modules for SFP Plus that give you 10 gig Ethernet over copper, RJ45 connector, or even 2.5 or 5 gig over copper, again, RJ45 connector. There are a number of different types of optics, both in the single mode and the multi-mode category. In the single mode category, the optics are often separated by their maximum range. And so this optic, for instance, is a 30-kilometer optic. And so you'll see in the single mode space, an optic may be 1 or 2 kilometers all the way up to 60 or 80 kilometers. The only gotcha in the single mode space is that some of the super long range optics, like the 60 or 80 kilometer optics, some of those do have a minimum optical length that you can use them on, and sometimes it can be 5 or 10 meters, sometimes it can be 100 meters. And so on the very long range optics, be where you should check that out and make sure that it'll work in your environment. And really, there's no reason why you'd want to use an 80-kilometer optic to go across the room, because they're pretty expensive. On the multi-mode optic space in the 10 gig world, a standard 10 gig over multi-mode fiber over OM3 can go 300 meters. There are, however, some places that now sell optics that are rated for smaller distances than that. There are some 50 and 70 meter optics for multi-mode, and those are really just done because they can use slightly cheaper transmitters and receivers, and so they're very inexpensive. There are optics, multi-mode optics for like the 70 meter that are like $10 or $12, so really, really, really inexpensive, which really contributes to why multi-mode in a single server room can be a really inexpensive way to have optic interconnects. And so after SFP Plus is SFP28. And SFP28, again, same form factor, but the electrical signaling is, instead of being 10 gigabit, it's 25 gigabit. And so you can buy SFP optics that are single mode or multi-mode that do 25 gigabit Ethernet over a single mode or a multi-mode fiber. There is not a copper standard for doing 25 gig, however, so it's just for optics. And so if you see a device that has an SFP28 port, then you know that can support up to 25 gigabit Ethernet interconnects. There are a lot of devices now that have a collection of SFP Plus ports and 1 or 2 SFP28 ports kind of meant for uplink, which can give you that 25 gigabit over a single multi-mode or single mode fiber. And so that's the SFP world. In the QSFP world, they have a sort of a direct parallel. So devices that are QSFP plus, the Q stands for quad, and so this just has 4 of the same channels that were in SFP plus. Remember, SFP plus is 10 gigabit, so these have 4 10 gigabit channels for a total of 40 gigabits of transfer rate. And these QSFP plus modules come in a variety of interconnect possibilities. This is one that has that MPO connector, which is that little combined connector that has up to 12 fibers in it. And so this uses 8 of those fibers to have basically 4 10 gig channels. And there are also optics in the QSFP plus space for a single mode or even a single multi-mode fiber. And in this space, you're looking at 40 gigabytes or gigabits of transfer rate total. There is also QSFP28, so equivalent to the SFP28. It's this bigger form factor that has 4 data lanes, and instead of being 10 gig, they're 25 gig. So this gives you 4 25 gigabit lanes for a total of 100 gigabits. And so there are QSFP28 optics for doing 100 gig over single mode and multi-mode, along with some doing over multi-mode, like there's an MPO 16 and an MPO 24 connector for doing multi-mode over multiple fibers. But if you want to do something like either 50 gig or 100 gig, you can do that in that QSFP 28 form factor. And so this is sort of the general range of what you're going to see in building something for a home lab. Most of the lower end gear has SFP plus and SFP 28. And then on the little higher end, you'll see a lot more of the 40 gig and then eventually the 50 and 100 gig interfaces. And so one other thing worth mentioning is I'm going to grab a DAC cable because it's worth mentioning that. Hold on just a second. Okay, so one thing worth knowing is that aside from having these modules that can do the single mode or multi-mode fiber optic interface, there are, of course, these modules that can do copper, RJ45, twisted pair, Ethernet, everything from 1 to 5 and 10 gig. You can also buy these modules called DACs. And these modules allow you to connect together 2 switches through the SFP plus ports. And it's using a copper interconnect. And the copper interconnect is actually just interconnecting the direct signals coming off of the internal sort of module connection. And these have the advantage that they're very inexpensive. Now, the distance they can do is everywhere from half a meter up to, I think the most is a little bit over 6 meters, almost 7 meters. And so beyond 7 meters, these don't work anymore, and you'll have to use an actual optical interface or RJ45 twisted pair. But these are an inexpensive way to connect switches together, and they have these DAC cables for SFP plus and SFP28, and they actually also have them for the QSFP 40 gig. You can buy DAC cables as well. And so these can be a somewhat inexpensive way to do. I think sometimes these cables are on the order of maybe $15 or $20, and it includes both ends. So it's a really, really, really inexpensive way to get a 10 gig interconnect between switches without having to actually use fiber, assuming your distances aren't greater than 6 meters. So something to keep in mind when you're deciding how you're going to interconnect your switchgear. And with that, hopefully that gives you a kind of a summary of what to think about in the idea of using fiber in your home lab. The prices have really dropped over the last 5 years, especially in the multimode fiber optic space. It's relatively easy to get optics. Actually, there is one other thing we should mention, which is that the interface, the electrical interface for these modules includes, of course, that 10 gig or 1 gig or 25 gig interface, but it also includes an interface to a EEPROM that is embedded in here, which is a little memory storage device. And that was done as part of the standard so that a device, when you plug this in, can query that EEPROM and read from it some standard information like the serial number and the type of device it is and the range the device has. And included in that was a place for putting in some vendor ID related information. And unfortunately, what that means is that some vendors, like Cisco, we did it, is well known for this, they make some of their products such that if you plug in an optic into their switch, it has to be one that has a Cisco signature in that EEPROM data block. And so as a result, if you go on a website and you look to buy some optics, you often see the optics listed as different part numbers for Cisco, for Juniper, for Arista, and then sometimes for generic. And that is because some switches like Cisco, Arista, and Juniper, and a couple of others require optics that have some specialized vendor ID or vendor information in there. And it can vary based off the switch. Some things like the older Arista 7000 switches there is a command you can do to turn off that verification so that you can use generic optics. I think that only works on some of the older switches. I think they eventually changed that. But be aware of that. So if you have a given switch brand, particularly if it's a large enterprise brand, you may have to buy optics that are programmed for that particular vendor ID. Now, there are some programmers. There's actually an open source SFP programmer, and there's a couple of good closed source ones too, that allow you to read and write the EEPROM in the module, and you can use those to duplicate those vendor codes. It works with most of them. There are some modules that actually have a password lock on being able to write to that memory, and so there's a little bit of hacking needed in some cases. But when you're buying optics, be aware of that. For things like Ubiquiti and MikroTik, they'll work with pretty much any vendor ID. They don't have a vendor ID lock in them, and so you can use almost any of the optics here on something like Ubiquiti, which is a great thing. So keep that in mind when you're looking to buy optics for your fiber optic environment. So with that, if you have any other questions, please put them in the comments below, and I will do my best to either answer them or make a video about it. Thank you very much.